Circles, circle angles, circles, circle angles. Students, please make note of both the location that you're watching the video as well as the date and time. The date and time. Let's review a previous problem. Have your Post-its handy, please. We're given the following information, and we want to find everything possible. So let's start with what we know here. Start with the simplest stuff. Trace this diameter. Now stretch out the diameter. We know diameters split circles in half. So we're going to sweep and we're going to put 180 here. And then we're going to sweep and put 180 here. Let's see, that actually gives us something right this very moment, because look very closely. We know from here to here and from here to here is 180 degrees. So we can do this. We know that 7x plus 11 plus 8x plus 4, therefore, must equal 180 degrees. Why? It's half a circle. Let's do our math. Collect like terms. I'm going to circle my x's. I'm going to box my numbers. 7 plus 8 is 15x plus 11 plus 4 is 15 equals 180. I'm going to minus 15 both sides. I end up with 15x equals 165. I'm going to do 165 divided by 15. I know that goes in there one time. Bring the 15 down. 15 goes in there 11 times. So I find that x equals 11. Now we're going to circle whatever x is, and we're going to bring it over here. We're going to find some measures. 7 times 11 is 77 plus 11. 77 plus 11 is 88. 8 times 11 is 88 plus 4 makes this 92. Now let's check in the margin. 88 plus 92. Let's see if we were accurate. 8 plus 2 is 10. Carry the 1. That's 9 plus 9 is 18. So check. They do add up to 180. So right now we have 88 and 92 as those two arcs. Let's see what else you can find here. Let's start framing our inscribed angles. Get your Post-its. And I first want you to frame this angle right here. Frame it up. Put your Post-its down, frame it up. Notice our arc here is 180. So our angle here, if it's inscribed, is half 180. Half of 180, that's 90 degrees. Let's move your Post-its. Let's frame the other angles. Let's frame this angle right here and see what we get. Put your Post-its down, framing this angle right here. We see it's inscribed. It grabs the 92 and it's here. We know the inscribed angle is half the arc. So we're going to go 92 and divide by 2. 2 goes in there 4 times. That's 8. 1, 2. 2 goes in there 6 times. So we know back here is 46 degrees. It's half. Now let's move your Post-its. And I'd like you to frame this last angle up. Actually, you don't even need to frame it up because we have 46 and we have 90. Let's add that up. Take it away from 180 because we have a triangle here. See the triangle? Triangles add up to 180. So let's check. 90 plus 46. And of course, that's 136. Let's take 136 away from 180. Of course, we get 44. Which, if you look, 44 reaches out and grabs the 88. That's half. We know we're correct. So our final three angles here, we have a 90 degree here, we have 44 here, and we have 46 in this corner. We have 180. We have a 92 degree arc and an 88 degree arc. Today we're going to be talking about circles and angles. We need to recap and remember what we have learned so far. Step 1, we have an inscribed angle. An inscribed angle is vertex on, arms in. So this would be considered an inscribed angle. Vertex on, arms in. A chord is just any segment whose endpoints are on the circle. So even part of an inscribed angle is made up of a chord. A tangent touches the circle at one point. From the outside, that would be considered a tangent. And a secant goes through the circle, intersecting at 2 points. Goes through the circle, intersecting at 2 points. So this would be considered a secant. Knowing that, there's 4 additional angles you need to be familiar with from what we've learned so far. What have we learned so far? We've learned about a central angle, which is connected to the center. We've learned about an inscribed angle, vertex on, arms in. We've learned about a tan-chord. So here's a tangent, and then a chord. That is a tan-chord. Sweep the angle, sweep the arc. Sweep the angle, sweep the arc, sweep the angle, sweep the arc. And then the other one we've learned about is the tan-tan, which is made up of 2 tangents. Whoop, that's not quite on there. Let's try to get that on. That's better. That would be considered a tan-tan angle. There's 3 additional angles you need to be comfortable with. 3 additional angles for a total of 7. The additional angles are a chord, which is an angle simply made up of 2 chords. So if you draw a chord, and now draw another chord, this pair of angles would be considered a chord. So technically, a chord has 2 angles. That's a chord. Why is it called a chord? It's made up of 2 chords. 2 additional angles would be the secant-secant. Secant starts from the outside of the circle and goes through the circle at 2 points. That's a secant. Secant could also go through the circle and just stop at that second point. That's also a secant. So this back here is called a secant-secant angle. And then if we have a tangent and a secant, that is called a tangent-secant angle. This is a tangent. This is a secant. So we have a total of 7 angles that you need to be familiar with. 7 angles total. Take a moment and try to memorize these angles. Stop the tape. There are a total of 7 angles that you need to have memorized what they look like and what they're made of. Pause the tape and see if you can't memorize these angles. Okay. These angles all have a very particular measure relationship to the arc. Step number 1, I'd like you to at least try to draw the angles that you just saw. Draw the angles and try to do this from memory. I'd like you to attempt to draw a central angle there. Draw an inscribed angle there. Draw a tan-chord angle here. Draw a chord angle here. Draw a secant-secant angle there. Draw a tangent-secant angle there. And I'd like you to draw a tan-tan there. Pause the tape and see if you can't draw those angles from memory. From memory. If not, flip the page and draw it again. Okay, welcome back. Let's see what you did. A central angle should look like this, connected to the center. Let me get those colors matching. An inscribed angle should look like this, vertex on, arms in. Vertex on, arms in. Tan-chord angle, you have a tangent and a chord. Then you have a chord. You have two chords intersecting. A secant-secant starts from the outside and goes through the circle at 2 points. That's a secant-secant. Tangent-secant, you have a tangent and a secant. Tangents intersect at 1, secants at 2. And then you have a tan-tan. All of these 7 angles have a particular relationship to their arcs that they are grabbing, to their arcs. To help you remember this relationship, we have a song. I'm going to sing the song once, and then we're going to sing it line by line and write down the measures of the arcs and the angles. Goes like so. If you can, get a beat. If you can listen to the snap, snap with me. Goes like so. Measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its plane. Tan-chord angle is the same as the one inscribed. Chord angles half the sum of the arc it strides. Secant-secant, tangent-secant, tangent-tan angles are all the difference of their arcs multiplied by half. Still snapping, so should you be. I'd like you to attempt to sing this with me. Ready? And go. Measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its plane. Tan-chord angle is the same as the one inscribed. Chord angles half the sum of the arc it strides. Secant-secant, tangent-secant, tangent-tan angles are all the difference of their arcs multiplied by half. Let's take a look at this and see what the actual equations are going to look like. It says measure of a central angle to its arc the same. So in this case, the angle equals the arc. In this one, the smaller angle of inscribed is half the arc it's playing, so the angle equals half the arc. Tan-chord angle is the same as the one inscribed. Inscribed is half. So this angle here is half the arc it's grabbing there. Please write this down. A chord angle's half the sum of the arcs it strides. Strides mean to straddle. So this angle here is half the sum of the arcs. So we write angle equals arc plus arc over 2. The last three have the exact same equation. Secant, secant, tangent, secant, tangent, tan angles are all the difference, that means subtract, of the arcs multiplied by half. So this angle here equals this arc minus this arc. Angle equals arc minus arc multiplied by half. That's the same as divide by 2. This angle here, angle equals arc minus arc over 2. This angle here equals arc minus arc over 2. The way I remember this is the vertex is outside the circle. When you take someone out of a game, you subtract. You take them out of the game. So out, subtract. Find the difference of the arcs multiplied by half. Now we're going to apply this to 4 simple problems. It is important that you actually have this memorized. So we're going to put one right next to the other. And the 4 steps we're going to use is we're going to trace the angle, and then we're going to identify what kind of angle is it. We're going to write down the equation, put a little equal sign there. We're going to circle, plug, chug, and solve. Circle, plug, chug, solve. Very important. Equation means there's 2 sides. An equation implies that something is equal to something else. Very important you write both sides of the equation. Let's do this first one here. Step number 1 is to just physically trace it and identify what kind of angle is it. So we see here that is a tangent, that is a chord. So this is a tan-chord angle. We have a tangent, we have a chord. So we come over here, tan-chord angle, and you identify tan-chord angle equals half the arc. So tan-chord angle equals the arc over 2. Let's identify what we have here. The tan-chord angle we don't have, we're going to call it X. The arc that it's grabbing sweeps around this way. It's 200 over 2. So our angle here, X, is 100 degrees. Let's try another one. Number 2. Let's first trace it. So physically trace it. Now come over here on the left and identify what kind of angle is this. We have a chord and a chord. So we're going to write our equation down. We're told a chord angle's half the sum of the arcs it strides. So angle, chord, angle equals arc plus arc over 2. Let's see what we can do with this. We have our equation. There's our angle, so we circle the angle, we plug it in. So that's X degrees. equals arc, circle the arc, circle the arc. 65, this is circle, plug, chug, plus circle the arc, 141 over 2. So our x degrees here, we're going to add 65 and 41. 141. We get 206 divided by 2. Our x degrees here is going to be 103, which technically is this as well because they're vertical angles. Let's try another one. Again, trace. Trace the angle and figure out what it is. Here we intersect the circle at 2 points, so this is a secant-secant. We identified our angle, now we write our equation down. Angle equals the bigger arc minus the smaller arc over 2. Remember, there's 2 sides to an equation. We have angle equals. That's a secant-secant angle. Now we're going to do circle, plug, chug. Circle, angle, whoops, now we have the angle. Be very careful here. We actually have the angle. Circle, arc, here's our big arc, 134, minus circle, smaller arc, whoops, we don't have the smaller arc. That's x over 2. Put this over 1. We're now going to cross multiply and solve. 2 times 46 is 92, equals 134 minus x. We subtract 134 from 92. We end up with the negatives, and be a double negative, so it'll just be positive here. So we're just going to subtract 9 from 14 is 42. So we find here that x must equal 42 degrees. Now let's do a check. Let's add 42, it's minus. Our check is arc minus arc, 134 minus 42 over 2. 134 equals 92 over 2, which equals 46. We got it. So our arc here is 42 degrees. Try our last one here. First we trace. And it only intersects at 1 point, so we see that we have a tan-tan angle here. We identify the angle. This is a tan-tan. Tan-tan angle is also big arc minus little arc over 2. Let's take a closer look at this. So we ask ourselves, do we have the angle? No, we don't. That's x. Equals, do we have the big arc? Yes, we do. The big arc goes from here all the way to here. So our big arc is 265 minus, whoops, we have an unknown here. Sweep it. We can't have 2 unknowns. We can't have an x and an additional unknown here. So let's see what we can do here. I'd like you to sweep your pencil around this circle like so. At this point, I'd like you to pause the video and see if you can't solve for x by yourself. Pause the video at this point and see if you can't solve for x by yourself. Okay, welcome back. Let's see what you figured out. By doing the circle, hopefully it jarred your memory that circles add up to 360. So to get this green angle, we do 360 minus 256. That's going to give us, 265. Got that backwards. Let's try this again. I didn't physically pick up my answer, so I made a mistake. So I'm going to physically pick up 265, and I'm going to write it down. And now I can do my math. That's 5. That's 9. That's 95. So our here is going to be 95, which means this is 95. So to solve for x, you do 265 minus 95 divided by 2. 265 minus 95 divided by 2. And we get 85 degrees. So our x here is 85 degrees. It is absolutely critical that you memorize this page.